Stylized grass can be one of the harder things to get right when making a game, and there's nothing worse than just throwing down a flat grass texture and calling it a day. But you don't have to be lazy, because it doesn't need to be hard, and I'm going to show you how. If you're not working with your own grass mesh, you can watch part 1 to learn how to create your own, or just download the source files on my website. Importing in Godot is as simple as placing the files into your project folder. We're working with the GLB file here. To use it for our grass, we need to extract the mesh resource file. Go to Advanced Import, click on the mesh, and then set Save to File as True, and select the location to save to, and then re-import. This places the mesh resource into our file system, so we can use it outside of the imported file. Now to spawn our grass, we're going to be using a multi-mesh 3D node. This is a more optimized way to render thousands of the same mesh instead of using the mesh instance 3D node. But first we need a mesh to use as a base. Let's add a mesh instance 3D node with a plane mesh and set that to a size of 10 meters by 10 meters. Next, add our multi-mesh 3D node into the scene, making sure it's not a child of the plane mesh we just added. Our node needs a new multi-mesh resource which will contain our grass. Now in a game setting, you would likely spawn the grass manually with a script or landscape system, but for now, we'll use the populate surface option in the multi-mesh menu in the toolbar. This tool allows us to select a target surface for our multi-mesh, the mesh we want to populate with, as well as some randomization options. We'll set the target surface to our plane and spawn 512 meshes with the following randomization settings. Since we're using our mesh setting here, we can delete the 2 dots in the source mesh field. Hitting populate gives us this. Let's double click our grass resource and adjust our surface settings there so we can make our new shader the default for our resource. Next, go to the surface, create a new shader material, and then a new shader creatively named grass. And before we start coding our shader, let's make another graphical change and turn off shadows on the multi-mesh. Enabling shadows can drag performance, and most stylized grass will have shadows off. Next, open up our new grass shader and add the following variables at the top. Color in Color 2 will create our grass color gradient. Noise will be used to generate random color variations in the grass, and noise scale allows us to adjust the size of our noise texture. And finally, world position will hold the world position of our grass vertices, which will be used to project the noise texture onto our grass. To get our vertices, we need to add a vertex function. Within that function, paste this line, which transforms the vertex position from a local space to world space. Within the fragment function, add this variable that will sample from our noise texture using the world position of each vertex, divided by our noise scale. Then we set our albedo to equal a lerp between our 2 colors, using the Y value of our UV. Because our blades of grass are scaled to fit the UV map, and therefore the range of values between 0 and 1, a lerp will create a gradient of our 2 colors over the length of our blades, resulting in this effect when we select our colors in the shader parameters. Before we add our noise overlay, we have one problem to fix with the mesh. The blades disappear when viewed from behind. This is because of something called back face culling. This can be disabled by adding this line near the top of our shader. And now our entire mesh is visible. Unfortunately, this creates a new problem with our normals, which affect the lighting of our mesh. The back of our mesh has the normals pointing the same way as the front, which gives us this two-tone shadow look. What we need is the backface normals to face the opposite way. This can be fixed by adding this code into the fragment shader, which states that if the pixel is not front-facing, set the normal value to its opposite, resulting in this. Finally, let's create our noise texture in the shader parameters, and then adjust our albedo code to add our noise. Then make some final color adjustments by creating a standard material for our plane and fine-tuning our 2 grass colors to match. And with our color set, we can bump our mesh number even higher to get the full effect. You can use different grass meshes, different noise settings, or different colors depending on your project needs. Now in the next video, we're going to be adding some wind to the grass to give it some life. Hey, if you made it this far, go ahead and leave a like, subscribe for more Godot content, and until next time, keep creating.